Welcome, everyone. Thanks for being here so early in the morning. My name is Mads Torgersen, but you probably know if you made it to this room. I'm the lead designer of C#. Have been for some time. Blame me. And I figured we'd take a look at mostly what's coming into the new version of C#, C# 14, that's coming out in November. But we can talk about other things as well. Including maybe towards the end. We have 75 minutes together. So towards the end, we can also, if we get there, we can talk about some of the things that we're thinking about further out in the future. But I'm also happy to reach back. And if you have questions along the way, I was just talking to Cameron up here about how we'll do, because I'll be doing live demo the whole way through. So if you have questions, we don't want to wait too long before we get them. We don't want to wait till the end because that code might not even exist anymore. So I'll probably stop a few. It'll be too hard with mics and so on to like ask questions all the time along the way, but I'll try to stop like 5, 6, 7 times along the way and we can get a mic out and get some questions going, okay? So really, we have a lot of time together today, and you have the opportunity to somewhat shape what we talk about, and we can drill deeper into the things you're more interested in. I just kind of want you to leave here with, a good understanding of what the next version of C# can do for you. And I will be around through lunch. Maybe if you see me in the hallways, just stop me if you want to chat more. The lunch has topic tables. There may be one for me. They said if I accepted the invite, there would be a table with my name on it, but we'll see. But I'll be there anyway. So if you think of something after, just chase me down and we can talk. Okay. With that, I'm going to start easy. I'm going to show you some of the like little niceties that C# 14 has. That means when we get to the big stuff, there may be more people in here at that time because it's the first talk of the day. And then we'll get to we'll get to the biggest feature last. Okay. So we already have the documentation up. There's a whole C# 14 tab here at learnmicrosoft.com. And all the features are already documented in there. There's a few, maybe just one that, and parts of other features that aren't quite done yet or didn't make it into the preview flag in VS. Okay, so everything I'm showing today, I'm showing with language version preview turned on in just regular VS preview channel, public preview channel. So if we go to this one here, for instance, I'm actually starting out with language version 13, which is the current one, and then we'll shift to language and preview in a second. But just to illustrate that you can all do this at home. Like everything I do on screen today, you can already go home. If you're in the preview channel, you can just play with it. It's all public bits at this point. Comes out in November with the rest of .NET. Okay? So let's just go right in. I'll start with I have some very contrived code here, and it's not designed. Don't do it like this at home. It's just designed to be able to show many of the features in the same code base. And let's just start with the first. Like a warning pops up. I'm still in C# 13. I get a warning that this thing might be null. Good old nullable reference types. How many people here have nullable reference types turned on in their projects? Okay, most of you. How many have it turned off, just to see how many are awake? And how many didn't answer the question? That was a few. It didn't add up, but it's fine. You don't have to participate. So nullable reference types will say, okay, this might be null. This one might return null, so it can't figure out whether this would be null. So it gives you a little warning. And up until now, if you really don't have many options here when it's on the left-hand side of an assignment, you could put a whole if around it if person is not null, you know, and wrap the whole thing in that. But, and I don't know why it doesn't indent nicely, but I'm probably doing something wrong. But, you know, now you're just pushing it to the next time you're trying to assign something to a member of it. And it's kind of laborious. You could also say, hey, I actually have a feature to make the warning go away. It's called the, you know, I can't even remember what it's called. The null forgiving operator, we sometimes call it. You just say, I don't care about it, you know, and then the warning goes away. That's a really bad choice, but syntactically, it's pretty nice, you know. Other places, for a while, you've had the null conditional operator, which is just a different, I guess, punctuation mark. And it doesn't work on the left-hand side of an assignment, so you get an error here. But if we upgrade to C#, like if you see what's offered here, it is just upgrade to language version preview, and this will start working. So I'm going to do that. The red squiggle takes a little, give it a second. This is an old machine, but the red squiggle, yeah, there it goes away. So apparently this is allowed. What happened over in my CS project is that it's now language version preview. So this is what you should do if you want to play with new features. What's happening here? It's a null conditional assignment. It means it's like if somebody, how many people have used the null conditional operator in other places before? A good number of you are familiar with it. Essentially, it says like, if this thing that I'm putting the question mark on is null, then don't do anything else. Like just stop right here. And the result is null. So that's what happens here as well. If person is null, we don't access the property. We don't evaluate the right-hand side. We don't do the assignment. You know, we just skip and result in null. So that now works for assignments as well. It's still pushing the thing down here, but we can do it again. We can say null conditional assignment here as well. And so that's just a little convenience, a feature that we're just extending a little more. And you see a lot of that. Like we're like, this is actually kind of annoying, or this feature wasn't broad enough to begin with. Let's apply it in some more places. So most C# features are actually like that. Just remove nuisances. Fewer moments where you're annoyed as a developer. We just kind of want you to be comfortable. So, all right. You see yourself using that? Okay, good. Thank you. Another one, and this is maybe not super common, but we've had lambdas now for, I think, 17 years in the language since we shipped lambdas. And the parameter lists for lambdas are either they have a long form or short form, right? This is the long form. You have the types of all the parameters. You have the modifiers as well. And the short form is that you just have the names. Okay, it's been like that for a while. But it's really annoying. If you just have like one parameter that needs a modifier, like the out parameter here, it's annoying that the whole thing has to go to the long form. And as of C# 14, we're like, actually, you can use modifiers in the short form. So now you don't get a red squiggle on the out as you would have up until now. Again, just a little nicety. Okay, starting in the light end here. Okay, let's find some more nice little things. Let's talk about partial for a bit, and then we'll take the first round of questions. So I have partial classes here. The person class is a partial class. And the idea here is, like, oftentimes you can use partial classes for many things. Just, you know, get your code kind of like nicely organized and structured, separation of concerns, whatever. But it's also really good for if you have source generation scenarios, which people have more and more. And that there'll be and what we're imagining here is that I wrote this part here and something generated the other part. Maybe looking at this part, a source generator produced the other one. Of course, I did actually write it. We didn't have a source generator do it, but just to imagine what's going on. Now, what you can do is, and what we've had for a long time, is partial methods, which can, you know, I can have a declaration of a partial methods in one part, and then I can have a definition in another part. right? And if one of them isn't there, we get errors. So if I comment this one out, we can go down here and see that the definition part of it now is an error because there isn't a corresponding declaration part. So they have to match up. They have to be paired. And that's really useful. Both in this case, I'm sort of like telling the source generator, hey, it's looking at my code and seeing, hey, there's a partial method there. Clearly, I meant to fill that in. I meant to provide the implementation. Sometimes it's the other way, that you have some generated code that is putting hooks in for you to fill out. It's like, I don't know how, like there's a callback essentially to the other part. So you can do it both in both directions. Really useful, but it only works for methods. And well, it up until recently. And then in C#13, we were like, hey, we should just allow partial properties. Why don't we allow partial properties? And so that's already a feature in C#13, but I'm going to show it here as well. Let's find a property. Let's see, here's a property. Let's say that this is a property that we would want the to have generated. So let's put it down here. And then what we really want is for it to be partial as well. Now we get an error saying, hey, you can't have a partial definition without a partial declaration. So let's look at the error there. Yeah, partial property must have a definition part. So let's go up here and give it one. Let's just put it here. And all we have to do is say it's get set. And actually, part of the reason why we didn't get around to doing this before is we had a little argument about, well, this looks just like an auto property, right? This because it has a getter and setter. And we just had, so how can you see if it's a definition part saying there should just be a getter and setter, or it's an auto property declaration part that's actually providing the implementation, and the implementation is that it's an auto property, right? How can you tell the difference? And eventually we just said, you just can't have this auto property syntax in your declaration of a partial property. Like you just don't get to do it with an auto property. With an asterisk, we'll come back to in a second. So this is the definition part, and that was really like now it just works, right? So now in C#13 we did properties and we did indexers, and in C#14 we got around to doing events and constructors as well. So we're kind of hitting all the member kinds one at a time. So this event here, instead of like that, could also have been generated now based on a specification up here. You don't have to say the accessors here. You can just specify a partial event and get the red squiggle saying you need a matching one, because I didn't make this one down here partial yet. Now I did, and now they add up, right? So now you can also say, here's an event, dear source generator, please implement this event. And now it can go to town on your properties, your methods, and events, all kind of using that partial member kind. Okay, so now is this going to be useful? How many people use partial members, partial methods already in the code bases? Just a few. Okay, so most of you don't have this kind of separation. How many people use partial classes? Many more. Okay, so generally you use it to separate parts of your code, but you don't use it to kind of have one code direct the other or have them match up and that kind of thing. Okay, good to know. Thank you. This is probably a good time if you have some questions to what we've already seen before it fades. Please raise your hands. I see Cameron up there with a mic. He got out of his chair and everything. He has a mic in his hand. Please have a question. Not yet? Question brain not on yet? Was that a question? Yeah. Hang on a second. We'll bring. Oh, for the recording. Either we get your mic or I'll have to repeat it.
Sure. What is the benefit of using partial for properties or events? Usually we use it, for classes when we use WPF, right? And then that makes sense. But what would be the benefit of using this from your example?
That's a really good question. It is a way that the compiler can help you make sure that two parts match up. Okay, so it lets one part specify that something is needed and another part provide it. oftentimes in those scenarios, one of those parts is a source generator. So that part of the code will be generated. So for instance, this is kind of WPF-like in a sense. So you could imagine, and some people do use partial properties, partial methods in particular, in I notify property change like scenarios. You could say, for instance, I have this property, but I don't want to be the one having to call the unchanged event or whatever. Like so you as a user could specify just that, and then a source generator could go and fill in the logic that triggers the event and all that kind of stuff. So this gives a source generator. This gives you a chance to hand off the tedium, the boilerplate code to a little source generator that just knows how to generate it for you. It's that kind of code that is very sort of schematic, very idiomatic. You just know it's the exact same code you're repeating again and again. Maybe pull that part of it out, have it generated so you don't forget to keep it up to date or have bugs in it. You just have it generated correctly, and you have a place where you can just see it's much easier to read the human written code now because it just says probably this, probably that, and then the source generator does the rest. So that's the kind of scenario. Does that make sense? And there's a question right next to you.
Just out of curiosity, the partial definition in line 13, could I have like custom logic within my setters or getters?
No. Not
Okay.
in the definition. This is sort of like, think of it, it's almost like an abstract property, except you don't override it by inheritance. You override it by having a partial definition somewhere else. Okay, so it has to be empty. It can't have a body. The getters and setters there have to have just semicolons, just like with abstract. Make sense? Yeah, cool. Anything else? It's a little dark, so apologies if I'm missing a hand. Then just, stand up and yell and wave your hand if I'm missing you. Otherwise, okay, let's move on. Thank you. Good questions. Okay, so I'm going to do, let's do one more little thing, and then we'll do a somewhat bigger thing. Okay, so this is definitely in the category of little things. But how many people use the Nameof feature? Yeah, really nice feature, right? Okay, it's kind of silly because it's just a longer syntax for having a string constant in your code. But the nice thing about it, of course, is that it's checked by the compiler that actually has to be a thing, that has to be a valid thing inside that has a name, right? So that's how it's useful. If you have use refactoring, it changes with it and so on. But when we did that in C#6, I think it was, we were in a bit of a hurry. Like, most of our engineers were off, we're building Roslyn, rebuilding the C# compiler from scratch. And so they're like, can you just do a very light C# version this time around? And we were sort of short on time. So we did the Nameof feature, but we cut a few corners. And one of the corners is, like, when I have a generic type in there, I have to give it a type argument. I have to put something between the angle brackets. But the result of the resulting string doesn't use that. It's just the name there, and it ignores everything between the angle brackets. You just have to give something valid there. And sometimes that's a little annoying if there are constraints, and you have to find something that actually satisfies the constraints and put it there just so that compiler can ignore it. And even if it's not hard to do, sometimes it's just verbose and silly, right? So finally, ladies and gentlemen, we allow you to not put anything between the angle brackets and still have a valid Nameof. As you can do with typeof, if anyone uses that. That's been valid with typeof all the time. Somehow we just didn't get to it with Nameof. Now we did. You're welcome. So let's get to something that's a little bigger. This is a feature that we've been talking about for a while, and this is where we come back to auto properties. That's the asterisk from before. Okay, so this property here, the name property, okay, we're saying it's machine generated by now, but ignore that. Let's say we're writing it ourselves. Is not an auto property. And why isn't it an auto property? It's because the setter needed to do just that one little extra thing And so we fell off the cliff, as we say. You can't use an auto property. We have to go and do everything manually. We have to implement both the accesses manually, and we have to declare our own backing field as well. You can't get any of that generated for you. The value of auto properties is A, generate a backing field, and B, generate accesses for you that are trivial, that just, go back and forth with the generated backing field. So it's kind of a shame, right? You fall off that cliff once you want to do one little thing. And we decided to take away that cliff. We've had a feature coming in for a couple of years now, and we're finally putting it in C# 14. It is in now, that we call field access and auto properties. And the way it works is, well, even if I want to do something, maybe even in just one of my setters, or one of my accessors, this can still be an auto property. So I could still have, for instance, the other accessor be an auto property. And I also don't want to generate my own backing field. Instead, what I want is a way for, I want auto properties to optionally have bodies in their accessors, but a way for those bodies to then access the generated backing field. And so we've introduced a keyword for that, a textual keyword called field, because that's what it's getting at, a field. And now this works. This is an auto property and it's an auto property because it either has, in this case it has both, but it either has empty accessors or it uses the field keyword explicitly in a non-empty accessor. So there are two different ways now that you can access the generated backing field, either explicitly or per usual implicitly. Okay, make sense? So it looks but you're welcome to implement both accesses if you want, and just access the backing field here as well. That was not. There we go. That was more red than I was expecting. Okay, so you can totally implement them both if you want to, but it's still an auto property because it uses the field keyword. It still generates a backing field. This has multiple benefits, right? The obvious one is it's shorter, but also maintaining your own backing field has downsides as well. One of them is that the other members can see it and they might interact with it directly instead of with the property, sometimes by accident, sometimes bypassing the checks that you put in your accessor logic, which may be the reason why you put it in a property, why you put a body in your property in the first place, right? So just the protection of nobody else can get, it's not called field, right? There's not a field called field. It has like some compiler generated name, and the keyword field let you access the one associated with this particular property. If you use it in another property, the field keyword accesses the backing field for that property, right? So they're hidden from other members, which gives you extra safety in your code. So it's really nice that you can do this in more cases. And so there you go. You're welcome, right? But there's one little thing that you should be aware of, which is this is a new keyword, and it's a thing that it's a contextual keyword. It only works there, but it's a thing that people just might have used the word field for something else. It's not the most rare noun in the world that you could have. Let's say so this would be valid code already in C# 13 and before if I said string ? Field there. If I had my own field called field, and then this down here used to refer to that field, right? It was just a variable name. Now it's a keyword and it means something else. And you can see that I get one, but so this is a breaking change in the language, okay? If you use the name field for your backing field for something you access from inside of a property accessor today, your code is slightly broken, right? Oops. So we decided to do this, but it was like we had to evaluate it a lot and think about different strategies for how to deal with this breaking change. It's a bigger breaking change than we usually do in C#, but we decided to go with it anyway because other feature designs, and we considered them like extensively, just weren't as good. We wanted the best feature for the future, so we did it. You do get a warning if there's something in scope that this would have meant in earlier versions. And then that means if you want to, and you can suppress the warning if you actually want it the new meaning. Or you can, if you can, you could go change the name of this to something else, because you probably shouldn't have things called field anymore. You should worry about that more. But also, if you meant the old thing, we can fix it for you, right? Let's see if we can get a fix here. We haven't built a fix for it yet. Looks like Copilot has it. Should we see what Copilot suggests for this? It's thinking. I have a feeling my internet is a little slow here. That's actually a good suggestion. Let's do that. Let's accept that. So what it does is it just says this.field. So have you ever been in a situation where we already have the value keyword in setters as well? It's not really a keyword. It's just a variable, but we color it blue. And sometimes you also have a thing out there called value. So there's already, like, if you have a thing called value in scope, and that's the one you wanted to get at in the setter, well, you would just say this.value to get around the thing that the setter puts in scope for you. And it's just the same strategy for field here. And it's grayed out, but again, that's just because there's a preview bits. It's not actually superfluous. It's telling you that it's using the thing called field that you declared rather than the new keyword. Okay. You could also, for this one, because field actually is a new keyword, you can also escape it. You know how, I don't know if you know this, but you can escape keywords. If you want to use keywords as identifiers, you can just escape them with an @ So that's another fix for you if you want. But this is the fix that works for both value and field. So that's probably the one we'll recommend. Okay, so this is the way to get around it. Hopefully we'll have fixes in there that aren't just Copilot, and options to do this everywhere. Like, just fix all my old code. So when you upgrade to C#14, you can just say, okay, every place I get this warning, just fix it to access the old things. And now you can freely use the field keyword and have it mean the new things. Okay, this is probably a good place for questions. This was sort of like the first big feature today. Any questions? This is totally blindingly obvious to you? Any haters? Anyone like this is stupid, don't do this? Like, any opinions? Just broadening. Yeah? Do you like it? Yeah. All right. Thank you. I mean, I should have asked that before. I'll ask that more. Okay. Well, I guess all our heartache about worries about putting this in were in vain, or we ended up doing it in a way that you feel reassured. It's, to be honest, it's a bit of a canary in a coal mine feature for us, because we're doing it's slightly more breaking than than we did before. We've had a few features in C#'s been around for a long time. We had a few times where we were like, this feature would be better if we had more courage to break a little more. And we put it in anyway, and we kind of have regrets, right? The first one that many of you are probably aware of is var. If you actually, I don't know if you've ever tried this, but if you go declare a class, public class var something, var, lowercase var as the class name, then when you say var something, it'll pick that up instead of, it won't use the var keyword. It will then instead be the type you declared. Because back when we put in var, we were so worried about breaking changes. And what if somebody had a class called lowercase var? We don't want to break that. And in hindsight now, so many years later, it seems silly, right? Of course, nobody would have a class called var. That would be stupid. Actually, people did have classes called var after we did that. Because some people hated var, and they're like, we put a class in called var, then they can't use the feature. There was a way to troll the team from using var. That's the only time I've seen types called var. So who were we breaking? Like, what were we doing there? And another one that I also regret is the discard feature. So I don't know if you use it much. You can sort of, let's see if there's a place where we can do something like that. You can say underscore equals, and underscore is a discard, right? It's it just means a variable that you'll never use again. And it's very useful, but of course, underscore is a valid identifier name. And so if you have something declared called underscore, then this doesn't mean that. And it just gets very messy. And in hindsight, I wish that we had more courage and done these features in the way that we're doing now. Just saying, hey, this means something else now. Would you like to fix up your code? I think C# would be better for it. And if this goes well, we'll probably take that stance in the future with that kind of feature. Okay. All right. Enough about breaking changes. They're so depressing. Let's switch gears and talk about the big feature, the biggest feature of C# 14. And we'll have a different demo for that. So that's extension members. Okay, so extension methods been around also for 17 years since we shipped them, C# 3. They're magnificent. We put them in to solve a particular problem, which was how do we get all these query methods onto IEnumerable? And it just turned out to be a really good idea to have the ability to put methods on existing types. For discoverability, it's just so great, right? You pull in, see, I care about these things, you pull them in with usings, and now they show up on the types where they're relevant, so they're super discoverable. You walk up to a variable of that type, you press dot, and it says, there's a where method, So architecturally, the kind of software engineering-wise, it's just a really good kind of separation of concerns, layering, while maintaining discoverability and readability kind of feature. And so obviously, about 4 seconds after we shipped this, people were like, hey, so where are my extension properties? And we're like, yeah, let's work on that. And we spent a lot of time in C# 4 trying to figure out extension properties and extension operators and so on. And we went down many dead ends because it turned out that the way that we had done extension methods didn't generalize to other member kinds. It's a syntactic hack, essentially, that only works for methods. And having to kind of back out of that and do something completely different and start over didn't feel like the right thing to do. And so we've revisited this several times in the intervening 17 years, and now we finally think that we've landed on a model that we think is a good compromise between respecting what's already there and the semantics we already kind of signed up for, while giving a new syntax that does generalize to other member kinds. So let me get into what I mean by all of that. So what I've done here is just snip out a few of the methods from system.link.enumerable. Right? I just took a few of them and put them in my own class. This is not how they're implemented nowadays, but these are simple, valid, and only somewhat cheeky implementations. Like loop, and if you find something, return it. And you only have a loop once. Don't worry about that. It's just to have a short member body here. But this is how you write extension methods today, right? So for it to be an extension method, it has to live in a static class, fine. And it has to have its first parameter with the modifier this designate the receiver type, okay? So you all know this. And what it really allows it to do is to pretend, this static method pretends that it's an instance method on something else. Okay, so this is sort of like it's cosplaying as an instance method. This is the kind of method it pretends to be, but it really is a static method that has a parameter. It has 1, not 0 parameters, and it also has a type parameter that it uses so that it can be generic in which IEnumerables it applies to. Okay. Unfortunately, only methods have type parameters, and only a few other member kinds have parameters. Properties don't have either. And so doing the same trick with property declarations, static properties or something, just wasn't realistic. We tried. And so we got to think of something else. And the thing we finally landed on here, the thing that is going to be in C# 14 is we said all these things that are specific to methods that only methods can do, let's take those and let's put them somewhere else. Let's have a new kind of declaration, what we call an extension block, that introduces the type parameters and receiver parameter of an extension. And then, actually, let's just keep it like this. Okay, like this. And then we don't need the this keyword anymore. We already have a keyword saying it's got to do with extensions. And then we put the extension members inside of that. So we've already set the difficult bit that they don't have syntax to express. And now we can put the rest of them inside. Extra layer solves the problem. So let's try to use that first with extension methods, like with the extension methods we have here. And then we'll get to talk about how we can, well, what other members look like. We've got to implement some other extension members. So let's start by just moving this first method inside here. And now we don't need to repeat the type parameter. We don't need to repeat the receiver parameter. They're already specified. What we really want is to give it the signature that it's pretending to have, right? So it's not pretending to be static. It's pretending to be an instance method, right? It's pretending to be callable on a value, not on a type. So remove the static there as well. And now the squirrels are gone, so we must have done something right. So and you can see that that's the one that we are calling now. So now apparently we wrote an extension method using a new syntax. And it's like an instance method in some ways. It has that same signature as if it had been an instance method. But the body is not what an instance method body would look like. Particularly, an instance method would refer to the receiver with the this keyword. And we debated that. We decided that's not how to do it. We keep it as a parameter with a parameter name, and it's declared up here on that shared extension block. And there's a reason for that, which is that when people write extension methods today, they actually often do parameter things with that parameter. It's not just a parameter. Maybe it's a ref parameter, especially if you have value types and you want to mutate them, it has to be a ref parameter. Or maybe you have actually some attributes on them that make sense. Maybe it has a not null attribute on it. Or maybe, it's actually nullable, right? There are extension methods out there that work fine on null. You want to be able to express that that's okay. So, and you see now we get a nice little warning on here saying, hey, it might be null. So all of this is useful, and we want you to be able to take your old extension methods and pull them into this new syntax, and they behave the same way, and you have the same options. So we kept it a parameter. And the thing I said about wanting you to be able to move your old extension methods forward, we really mean that, and we really lean into that. So that's interesting because one of the things that existing extension methods can do is that you can call them as static methods. That right? If you can't call them as extension methods, you want to, for some reason, like there might be multiple of the same name, you have to disambiguate, or you might, a later version of the class actually has an instance member that is shadowing the extension member, or something like that. Like you want to call it you want to have a syntax to fall back to call it when it doesn't work out as an extension method. And the way you do that is you call it on the static class that it's in, just call it as a static method. And you see here that first actually still shows up as a static method on the static class. We didn't write it like that, but the compiler still generates that for you from what you wrote. Okay, so it looks exactly like the one we just moved away from. It's still there. It's really still an extension method that still exists for real in the metadata. If some old C# compiler or a compiler of VB or another language that doesn't have this feature, if they see it, they will still consume it as an extension method. They won't know the difference because it is exactly the same. The only difference is we put a few extra things in there to tell the new C# compiler that it was actually written using the new syntax and what was written there. So you can totally still do this. And, we could call it with Q there, for instance, to get the first character of whatever string that returned. So that's one big value proposition I can't emphasize enough. It is completely safe to move every existing extension method that you want to forward to the new syntax or keep it in the old. You decide. But as soon as you kind of want to introduce other kinds of extension members, maybe which can only be expressed in this new syntactic paradigm, maybe it's nice to have them all together. And so your old extension methods can just go join them there if you feel like. We're not breaking anyone by using, and you're not risking anything by using the new syntax. Okay, let's move one more extension method up there just to kind of stress the point. And then I promise you we will get to other member kinds, because I'm really just showing you other syntax for doing something you already could do. So I'm moving the select method up as well. It's just a little more interesting because we remove the things that are declared up in the extension block header there, the tSource type parameter, but there is another type parameter and we're keeping it. Oh, and we have to remove the static as well, again, because it's still like pretending to be an instance method. And then we remove the receiver parameter, but we have another parameter as well. So it's just a slightly more advanced example in that some of the type parameters and parameters are removed and some of them stay there. And again, if we go and call it, if we say .select here, then again, there's a static method that it reassembles from the parts. Okay, so again, the static method that you had before is still available. You're just using a new syntax to declare it. Okay, hopefully this shows this shows how extension methods work. So what about those properties? What about extension properties that motivated the whole thing? Well, this is pretending to be an instance method. Let's have it pretend to be an instance property instead. So maybe we say open curly get, close curly. Yeah, that seemed to work. Okay. That was surprisingly easy. So you can kind of see now how other member kinds can now effortlessly be declared from a syntactic point of view, because you just do what you would have done if they had been real members. Oddly, you can still call it as a method, but that's because the real one from the actual system link enumerable is still there. So that's the one that's calling now. But we can go and use it as a property, and that works fine. You can even have setters. We are not going to allow you to have anything with like extension fields or anything with state, right? So you can't put an extension field in, because where would we put it? Like we can't, but where does it even live? Because we can't go change, we don't want to actually change the original object. But you can still have a setter, and it might, there might be a side table. If you want a setter, you can have it. It's probably not going to be common to have extension setters, but when you want it, no reason to disallow it. And so now we can totally assign to that property. We can assign, I don't know, 4. And that works because it has a setter. Let's not do that though, because it is odd. Now, apparently I don't have a static method called first anymore, and maybe that's not surprising. But we kind of want to disambiguate. Also, when you're calling a property, we want to be able to bypass the extension way of accessing it. So what actually happens? Do we have a static thing that we can call here? And what we landed on is that, yes, we do. There are 2 static methods. There's one for each accessor. They're called set_first and get_first. And I don't know if you know, because we've gone to great pains to hide it, but that's actually how all properties work and have always worked. Whenever you write a property, we generate a method called set_property name and get_property name, and then a little thing to represent the actual property. So each of the accessors is implemented as a method in like IL, as lower term method. It's just that we hide those methods from you and we don't let you use those names, so you never see it. So that's how it already works. And so all we're doing here is really saying, let's not hide these ones, because then you can call them as a fallback if you want to call the accessor as a stat. And now it's a static method. You see, set here, let's look at the getter. It's a static method, and it can take type parameters and parameters. So now it does take, I can't click on that. Let's do that again. There it is. There it is. So it has a type parameter for the type parameter of the enclosing extension block, and it has the receiver parameter right there, right? So That's how it's implemented. And you can call it like that if you want. You can say get first of Q here, and that gets the first character of the string Q. Okay, so that's kind of how it all comes together. This is relying on exposing these maybe slightly ugly methods. I don't know if it's the best way to do disambiguation, but it's fairly rare that you have to do it. So we were like, let's not do anything special for that. Let's just expose these methods. And if you all use it for a bit and common scenarios emerge that are like, this is horrid, can you do something like actually in the language instead of having these terrible methods that we have to call? Then we'll just add something, right? We can just add something to the language at that point. But for now, we're just going with that, saying, okay, that's probably good enough. Okay. So there you have it. That's your first extension property. Do you like it? How many people use extension methods, right? Extension methods. That's almost all of you. How many people think they will also be writing extension properties now? Okay, that's a good amount of you. Okay, excellent. Good to see. So you can try them out right now. Tell us already now if something doesn't work the way you expect or you want. And of course, keep telling us what you like and don't like about it. We don't have all the different member kinds in C#14. Another thing that we do have that I can show you is extension static members. So let's do a static method in a second. And we're also adding extension operators, actually. They're not in this preview yet, so you can't play with them. They're coming in right now. So hopefully there isn't a big problem with them and we have to pull them. But barring that, extension operators will also be there. So we're notably not covering indexers or constructors at this point. Probably a few other things I'm not thinking of. But we'll get to those as we kind of, in the order that we kind of see demand for. We're also not adding extension user-defined conversions, and we don't know if we should. But if we decide that we should, we can also do that. But they're not part of the operator. We explicitly exempt those because how do we feel about somebody else adding how do you feel about somebody else adding conversions to your type? Like maybe even implicit conversions. Is that too weird? Is that too dangerous? Maybe not, because you can already have the other type that you're converting to do that, add a conversion to you, right? So we don't know. So we just we'll wait and see. And as you've seen us do often, feature sets can evolve over time, over multiple versions of C#. And we kind of see what you all do, what you all want, and take our cues from that. Any questions? Let's do the static method as well, and then we'll do questions. Because it's really easy. Except we'll do a few fun things with it. In system link enumerable, there's this range method. I don't know why I've collapsed it here. There's this range method, and it's not actually an extension method. It's just a helper method, right? You can go, if you know where to find it, you can actually go and create a range of ints. Except, who would think to go and look at system link enumerable as a type and say dot? Right? It's not very discoverable. Maybe it's actually, a factory method really for enumerable event, right? So maybe why don't we put it on? Factory methods are often on the type that they create, static factories. Let's put it on there, just for funsies. So let's do a extension of enumerable of int. Let's call that source as well. Open block, close block. Oh, and that seems to just work. So I just extended enumerable of int with a static method called range. Okay. How does that work? Well, first of all, let's look here. It's still available in the sort of fallback. You can still call it on myEnumerable. Right? It's still a static method on myEnumerable. It hasn't changed at all because we don't have extra parameters. There's no extra parameter for receiver because it's a static method. So nothing's changed. It's still just takes the same arguments you can see there. But also, so let's call it. And sometimes Copilot has a suggestion, but apparently not today. Let's do this. But also, We can assign it to something just to keep that. But what we wanted to do was make it accessible on another type. So if we put IEnumerable of int here, that was the type we wanted it on. If you can see that seems to work. If you press dot, you can see it now has a range method. So now it's discoverable on the thing that it creates. That's very nice. Actually, when we did, so just to show one more feature here, when we did this method, we didn't have generic math. Now we have generic math. Do you guys know about it? We have INumber and stuff like that. So actually, it'd be nice if we could have a range of whichever numeric type we want. Well, that's an easy fix here. We just make the extension generic. Let's say tNumber. And then we extend IEnumerable of tNumber with that. And we have to use tNumber in the right places down here as well. So let's go through and fix. And the start should also be a tNumber, but the count should be an int. Now, that doesn't, and I should spell it correctly. Now, of course, I can't plus any old type that comes in, but this is where generic math comes in. You can say where tNumber is an INumber of tNumber. And that means that all the operators, all the numeric operators are going to be on tNumber. That's what that constraint means. And so now start plus plus seems to just work. So apparently I can increment whatever number comes in here. Well, that's cool. So int is definitely one of those. So this still works. But I could also use long. That seems to still work. Or I could use, let's try ulong. Now it doesn't work anymore. But that's because ulong is still a number, but one cannot convert to ulong. So that's the problem here. But we can make it unsigned, and now it works again. Okay, so I now have a better range method, more general, and it sits in a slightly more discoverable place. And I got to show you that extension blocks can also have constraints on the type parameters they introduce. But maybe it's not as discoverable as it would be, actually, come to think of it. Maybe it would be better if it actually just sat on the number type itself, right? I want to create a range of this number. That kind of makes sense as well. So we can just go and use tNumber directly here as the receiver type for the static method. Now this doesn't work anymore, but if we just say ulong, now it does, right? Now it's super discoverable. I can work up to any numeric type, anything that implements INumber, and all the numeric types do, and many user-defined types as well. Press dot, and there's a range method for it. Right? Cool. So it kind of all comes together. I think static extension methods can be really good for exposing factory methods in places that make sense. Like say you introduce a new type and you want to add a factory method to an existing type that takes that new type, like an overload of a create method or something like that. Now you can do that with extension members, with extension static methods. Okay? So that's the scenario for that. Okay. Now I think I blasted a lot of stuff at you. Now it's time for questions. I'm sure you have some. Yes, we have one down here. Microphone is on its way. 5, 4, 3, 2, 1. Thanks, Cameron.
Can I do the property as auto-implemented? Or can I reference on static background variables, or how it's...
You cannot use auto properties because they generate a field. And we don't know how to add the state to an existing object with an existing type. So because we don't do extension fields, we also don't do extension auto properties, and we don't do extension field-like events either, right? However, we could allow, I don't think we will allow fields ever, because we would have to implement it in a sneaky way under the hood, like a side table or something like that. If the compiler does that and it just looks like a field, then it feels like we're cheating in terms of what the performance profile is of using that field. Like it looks like you're just accessing a field, but really you're looking up in some big table and it's expensive and possibly like, I don't know. So we're probably not going to do that. We could do static fields, static extension fields. We haven't yet, but we could do that because those we can, there's a place we could put those. Those we can just put in the static class. They could live there. So that is, so to your question, it's possible that there will be static fields and then we could have auto properties. And if we do extension events, we could have field-like static events as well. That's probably like a niche thing though. So, but other than that, for now, we would rather that you do, like if you want to expose, if you want to pretend that you're adding state to an object, you have to write the logic that makes it happen and kind of make that clear in the code that you're using like a weak table or whatever they're called, and you're keeping that in a static field, and you're kind of, whatever mechanism you want to do to add state to an existing object on the side, you should do that. We are not going to do it for you. Maybe a source generator will do it for you. So that's where we're at, the design thinking currently. If, but this is the kind of thing that if we get feedback that we're thinking about it wrong, we will think about it again. So could happen. Thank you. Okay, next question. Oh, you have 15 more minutes with me. There's one up there. Yes. You really get some exercise, Cameron. I'm
doing my best.
I appreciate you doing that. And in 15 minutes, you can go and have coffee. And the coffee station is right outside. So if I end on time, you might get there, get in line first. Here, sorry.
Okay.
Oh, two. Okay, so there's one in a little further in front after. Let's just keep.
Yeah, I want to ask about a previous topic.
Yeah.
It's regarding the auto property.
The field the field keyword.
Yes.
Let's go back to the code base then. Okay.
I have a feeling that we don't need the field keyword here. You can get away with just the value. Why did you introduce the field?
It's because value already means something else, right? So in the setter, you actually want to be able to use both field and value. Value means, if you mean, why don't we just reuse value?
Yes.
It's because you want to be able to say this, field equals value. Value comes in as the parameter, and field is the backing field. Okay. Right? So value is the value that comes into the setter every time it's invoked, and field holds the state between those invocations. And you want to be able to, if you make those two the same thing, then you're kind of making it so that people can't access both, or they can't treat them differently. So we do need both for the setters. That's the reason why.
In C++, when you initialize, you can just say, you can reuse the same name of the variable, even if it's a member variable, right? You can say value, open parenthesis, value, right? And then it means you initialize the member value with incoming parameter value, right?
Okay,
That's fine.
Yeah.
But here you didn't want to introduce a syntax where value equal value, right?
We don't want value to mean two different things.
Right, okay.
That's true.
Yeah.
And also, even that wouldn't have worked to prevent a breaking change anyway, because if we had used value, it would already mean something today, in the setter at least, right? So now we would change the meaning of it in a sense, potentially. But also in the getter, there's nothing called value today, and so adding it would still be a breaking change. It was just as big a breaking change to the getter as adding field. So we didn't really think there was much value in reusing value and trying to make that work.
Okay, thank you.
Okay. Wasn't going for a pun there, but it kind of just snuck up on me. Apologies. Actually, let me go back to these being fields if you're talking more about this. Okay. Next question. Go ahead.
I don't mean to get ahead of you, but I did see your solution with unions up. Are we going to cover a bit of that today?
Yeah. I mean, either we have 15 minutes of questions now, or we might talk about unions a little bit. I didn't put them up there by accident. Let's put it like that. So this could either be a good segue, or we definitely had time for another question or two before we get there. And again, I can't necessarily see you super well, so anyone? Here.
Speak. All right. So I also have a question about this field keyword. So in case of dot setter, are we responsible for setting the field to the value in case of implementing the setter, or does it happen anyway automatically?
Great question. And the answer is, once you put a body there, you're in charge.
All right.
Because a big reason for putting a body might be that you want to set field to something else than the value. And you're like, what would that be? The value is the thing, right? But it could be that you just want to trim it before you, like it has white space on it. Let's just, trim that off before we put it into the field. So we don't want to presume that you just want to pass it through, and we don't do it for you. You have to do it yourself. If you even want to set, it might also be that you don't want to set it at all. Actually, maybe it's expensive to set it or something, and you want to do a check to see if you need to set it. Whatever. So you take over, you decide, and we're not trying to guess what you want to do at that point. Okay? Any more questions? And again, if you think of more, then I will be around. I'll be around some during the morning here, and I'll be around for that lunch. So you can track me down until then. And if you think of something after that, I'm mats.torgersen@microsoft.com, and you can just shoot me an email. I'll be happy to hear what you think. Okay. With that, we have about 10 minutes. And I do want to kind of just touch on something that has been in the air for a while. Okay. More and more of our competitor/friendly neighbor programming languages have things called union types. And they're kind of two. So spoiler alert, we want to add union types to C# as well. We've wanted to for a while, but we've had a really hard time landing on what the right model for it is, like how to do it. And now we think we've landed on it. So let me just switch to a file that has something. We haven't implemented anything yet. This is all smoke and mirrors. It's just to have something to show you. I just put this together yesterday to have something to show you about what our plans are. We don't have a single engineer actually working on it yet. But we're quite far along with language design around it. So the kinds of unions that we are doing in C#, we're calling them nominal type unions. Okay, and that is a long name. Maybe the actual feature name when we ship will just be unions, but it's a long name to express some important design decisions that we did that to kind of land us on how we're going to do it. Okay, so let's break it down. There are two. Let's talk about, first of all, briefly, there are two kinds of unions that people have experience with from other languages the most, that they kind of have in mind when they talk to us about unions. And those are very different, depending on whether you're primarily from a functional language background or you've spent a lot of time in TypeScript. Okay. TypeScript has this notion of unions that is what we will call type unions. You can just say, as a type, you can say this method returns string or int. String or int is a union type. You can just say it right there. So that's really like a union of two types. In functional language, unions are not type unions. They are discriminated unions, and you declare a union type with a name, and then you name each of the cases of the union type, saying it's either a this or that or those, but those are not type names. They're like tags that you use to identify the cases of the union type. So there are two differences. The discriminated unions in functional languages, they are nominal unions in the sense that they're declared and have a name, whereas the TypeScript ones are structural unions. You can just say union types with a type expression. You don't have to name them. The other difference is that these are what we could call tagged unions, and these are type unions. Okay. So in that space, and with people fervently wanting either of those, what do we do in C#? And we landed somewhere in the middle where we say they are type unions like TypeScript, but they are nominal like the functional languages, like F#. Okay? So you do have to declare your union types, but when you do, you can declare them as unions of existing types. So look at this syntax, which is weirdly gray because it's really just a region with some other code inside. Okay, it's a union. We called it pet. It's nominal. It has a name of dog, cat, or bird, which are existing types that I put right next to it here, but they don't have to live anywhere near it. They can be existing types that have been around for a million years. They can be object. They can be any interface or delegate type or whatever is already out there. And so the union type is declared completely independent, or can be declared completely independent of the types it's comprised of. And then when you have a union type, you can go as an implicit conversion from the case types, as we call them, to the union. So you can just go and create a pet object from a dog object here, or pet value from a dog value, okay? Implicit conversion, so that's how you get them. And then there is pattern matching that lets you just switch on a union type and then use pattern, and the patterns are then applied against its contents, right? So these type patterns here, and if you don't do much pattern matching, well, you should get into that if you want to use unions. These are now like applied to whatever is inside, and what you, no, let's get to that in a second. Actually, let's do it now. When you have a switch like this today, like let's say pet was just of type object, then there'll be a warning on this switch saying, hey, you're not handling all the cases. There could be so many more different kinds of types here. You're not handling all. You have to have a catch-all or something. But with union types, we know it can only be dog, cat, or birds. You're not going to get this warning. They're exhaustive. That's what we say. You have an exhaustive list of all the kinds of things they can be. Which is very different from inheritance, for instance, where you always can have, unknown derived types. So that's how it's going to work. How it's going to work under the hood is also quite simple. Essentially, and we might add a few bits and bobs on top of that, but the core model is the way we actually lower, the way we implement this new union type. We don't have anything new in the runtime or whatever. We just lower it. We lower it to a struct. Okay, it's just a struct. And it just wraps a single object reference, which is where the content lives. We call that's exposed in a getter-only property called value. And then we have a constructor for each of the case types. So you can create it from a dog, from a cat, or a bird. And then when you ask about the value, and this is public, everybody can get at the property directly if they want to, then you get back whatever it was. There could be other data layouts. If some of these types are value types, that means they get boxed in order to get stored in there. And if it's high performance, you might not like that. We have ideas for how to help with that. Essentially, letting people can manually write their own union types with different storage layout if they absolutely want to, is our answer to that. But for most things, this will be just fine. Most things are objects, and it's quite efficient to just keep them in a single object field. And then when we switch, what we actually do when we switch on a union type is essentially, it's abbreviating a little here, but essentially we just switch on the value instead. We get that value property out, and then we switch on it. But right here, I'm getting that warning, that exhaustiveness warning, because I haven't actually implemented this feature yet. I'm just smoke and mirrors. But the compiler will know not to have that warning when we do it because you're switching on a union type. And that's it. That's all the magic there is to it. So I feel like it's a very simple model, both in terms of usage and in terms of how it's implemented under the hood, understanding what it actually does. I hope that's true. We're planning to get to work on it within a month or two when people start freeing up from putting the last touches on C# 14, so we can get really early prototypes that we can get into your hands under the preview flag, that we can get into our library teams and internal partners' hands, so they can start building things on top of it that could also release at the same time. So if this all works out, the next C# 15, November of next year, we could have, and this is just me not promising anything, but we could have both union types and quite extensive use of them in our core libraries and frameworks. That's kind of the timeline that we're aiming for. So that's a story on unions. Any questions on that? We have time for one or two. The suspense is building. You receive it.
So with this new feature, let's say you had a API call to F# microservices or something, the discriminated support within that already exists in F#, is it supported?
So that is a great question. So when we add something new like this, that is a question we always ask ourselves: how does it interoperate with the other .NET languages that we are involved in, that is F# and VB? And I would hope that the answer is yes. We'd have to figure out how. It's interesting because F# already has discriminated unions, but they're different from these.
It's a standout feature for things that to date C# cannot do.
Yeah.
Anywhere, right.
Discriminated unions in F# are to F# what inheritance is to C#. They are their data modeling Swiss Army knife, right? And they have never worked well with C#. That has never been a good interrupt. Now we have actually a chance to express them better, to recognize them as unions in C#. And it is a goal for us that existing union types, be they from other languages or types that people wrote as best they could to try to emulate union behavior, that they can be integrated as well.
The other thing that stands out to me is that if I'm thinking in F#, that those top 10 lines would not compile because you couldn't reference pet until you'd already passed what the definition of dog, cat, and bird are. But I know that's not true in C#.
Right. So that's a big difference is that in F#, the cases have to be declared with the union type. And those names come into being together with the union type. And in C#, that doesn't have to be the case. You're welcome to declare them next to it. And we might even have special syntax for that case. Like that's one of the open questions. But that's just a fundamental difference. Yeah.
Right.
Yeah. Thanks for pointing that out. Yeah, because union types have been craved for so long, and this was the last, sorry, we don't have time for more questions. Because they've been craved for so long and the scenarios are really there, people have been getting by. And so both for interrupt and for accommodating those cases, we think that there will be a way, essentially, I have an iUnion interface here, and we're going to just say, if you implement iUnion and you kind of have, your type has the right shape, we will treat it as a union type, even though you didn't use the C# union feature to implement it. And that's kind of our gateway for all those existing union types to compatibly move forward, but also now be consumable with those new union features, like the implicit conversion, the implicit indirection and pattern matching, and the exhaustiveness checking in switches. And with that, I hope I painted a bit of a vision there. We're out of time. Find me, ask me more questions. Hope you enjoyed this. Hope you will enjoy C# 14. Thank you very much.